Well, hello everyone. My name is Khaldon Batnij. I'm a consultant here at SIS-TECH, and today I'll be presenting about 2008 uncontrolled release of Oleum. Just to give you a quick introduction, it happened during a transfer operation of Oleum, and Oleum overflowed from a tank, and it had potential of lethal impact on the public and the personnel. This was caused mainly by undermanaged equipment change, and we will go over all this as we go through it. So a little background about the chemistry in the plant. Oleum is known as humic sulfuric acid. It's a very dense, visible, slow-moving. You can see it while it's coming, and it's very toxic. It could cause respiratory damage, irritation, and even death. They manned the weekends without the staff, so it was only just the operators by themselves doing the work. And they did this to transfer the oleum from the pressure vessels to the process tanks, so they can continue operation on Monday. Every one of the process tanks that they had in the facility, they had two level sensing devices, a high level sensing device and a high level sensing device. The high level sensing device would give an analog continuous reading of the level of volume in the process tank and displays it in the DCS. And the high level probe, it was a fixed probe, and it would give an alarm if there's a high level volume, dangerous level. And it would also shut off, using an interlock, it would shut off a normal power supply from the pumps. Well, also, both of these sensors had alarms hooked up to them that would fire, depending if it's a high alarm or high level alarm. And those are visual and auditory in the plant, like in the storage building and also in the control room. So what did they change in the beginning, 28 years before it actually happened? They installed a flexible cord that was an emergency power supply. The reason why they installed this is because the normal power supply would sometimes go out of service, and it would actually happen very often, and it would be very hard to replace it and fix it. So they installed an emergency power supply, just temporary, just so whenever the normal power supply goes out, they use the emergency power supply instead. And after about a year, they took it out and they installed the wiring and conduit, almost making it permanent. So that's a picture of the emergency power supply is over here. This is after a year of installing it. They took out the flexible cord, they put it in conduit, and that's a normal power supply. And there's a switch on it, you can see on top. It's important to note that the facility did not install any kind of interlocks on this. They basically relied on the operators to switch off the emergency power supply locally. So they would have to switch it off from where that showed you in the picture. And they have also intentionally chose not to update the key documents. So for 28 years, they didn't have any kind of documentations over this or anything. They just installed it. They made it almost permanent. 28 years. Nothing is documented about it. So what was the proper procedure for the operators? What we're supposed to do during the transfer of volume? So they're supposed to hook up each one of these pumps to a normal power supply. They do it one by one. So they turn this on, they pump, they go to the second one, they pump, they go to the third one by one. And the emergency power supply was only to be used whenever, just like I mentioned earlier, only when the normal power supply goes out of service. They only use one at a time. So during the incident, well, it's been 28 years, and this emergency power supply hasn't been documented, So the operators saw the opportunity of using the emergency power supply as a second power supply. So instead of pumping only one at a time, we'll pump two at a time. They changed the procedure, and staff didn't know about this because it's not documented. Alright, so the day of the incident, this is what happened. At around 2 p.m., the operator was about to be done with his shift. You know, he shut off the normal power supply using the DCS and the emergency power supply, and he left the facility, leaving the emergency power supply providing power to the pump. Forgot to take it off, forgot to shut it down. So it kept pumping oleum while he's not there. And about 15 minutes later, the high-level alarm went off, but nobody was in the facility. He's already left. This is the weekend. And then about like 10 minutes later, the high-level alarm fired. And of course, it didn't shut off the emergency power supply because there is no interlock. There is no safety systems on this. It's relying only on the operators. So it kept pumping. And about an hour later, the conservation vents got filled with oleum, started escaping, all the sulfuric acid started escaping, the fuming sulfuric acid. And about an hour after that, emergency was declared. The operators outside the building, they saw the fumes coming out. So they reported it, they declared an emergency, and hazmat team was called for the incident. So what was the aftermath? So 3 towns were evacuated, Petrolia, Fairview, and Bruin. There's about 2,500 residents in them, and it was declared an emergency, so they sent them all, they evacuated and told some of them, to go to shelter-in-place locations like high schools and community colleges. Fortunately, the emergency did not cause any major injuries. Only one minor injury happened. So what were the implementation gaps? What did the facility miss that made this mess? The emergency power supply was installed without any interlocks. Only relied on operators to switch it off. That's one of the major ones. After the high level alarm fired, nobody was in the facility. It kept pumping. The interlock didn't shut it off. There was no documentations about this emergency power supply. So during the audits, like look at the PID, emergency power supply is not there. They don't know it even existed. So there was no changes in documents to document this. We need to make sure that whenever we make any change, it has to match the level of safety of the rest of the facility. Of everything that's already in there, whatever we install something new, whatever changes we make, it has to be in the same level of safety. In this case, the interlock was the high safety level. It wasn't installed in the emergency power supply. And of course, we also need to make audits to check if there's any management change issues, and that's pretty much it. Thank you all.